Now, there's three types of memory that C programs deal with. First is the stack. Now, all variables, that are just declared like you see here, tend to go on the stack. Okay, the stack space is pretty limited. It's really only maybe 3 or 4 meg, so I hear, typically. But you stick a variable on the stack, and stacks build up, by pushing values onto it, and then ultimately you pop values off of it. But understand this, and this is something that always confused me, but it turns out that functions and so forth, because I always known that when functions are called, I've always heard, that when you call like one of these functions and pass it variables, okay, well the variables are on the stack, right? And I think in my Chili files, I think I got some videos I recorded from Chili talking about this. But at any rate, in the stack, these variables get stuck on the stack, and then the function's called. Okay, the variables are pushed on the stack, along with, of course, the status registers and all that stuff. And the function, is then called. Okay. I guess the return address too is also, for the IP is also put on there. But, anyway, but the function's called and it's got those variables on the stack. But as it turns out, the function doesn't have to pop values off the stack to read the variables. It can actually read the stack laterally, because it can actually identify the references, as it turns out. So that was fascinating. To hear that. So it doesn't have to pop values off the stack, but it can modify those values while they're on the stack. So when the function returns, it does start popping values off, okay, as the need arises. And, well, guess what? Because like any temporary variables your function creates will also be put on the stack on top of these variables. But when the function's terminated, it'll pop those temporary values off and just get rid of them. Okay, but that still leaves your original variables, which may be, which are going to be still scope limited to whatever function called it, or what have you. But, the point is that they're still there, for doing something with, for your program to do something with. But like I said, that's the stack for you. But, there's also the heap, which is a massive amount of memory, which you can actually put stuff into, and we'll talk about that later. But classes and things like that, you can create an instance of a class on the stack, which, like I said, it's got limited space, so, you're going to run into trouble if your programs get too big and sophisticated. So you can put it out on the heap, okay, which you can create unlimited, almost unlimited, except by your physical memory and the virtual memory in your computer, I suppose. Objects out there, including arrays of objects, massive objects, and linked lists, and crazy things like that. But you can put all that out there, on the heap, and that's just a great general storage place. But you can't actually name the variables. You've got to use pointers to address the stuff you put on the heap. Otherwise, because you can't just name a variable like you can here, like down here, you can't have a variable name associated with it. You can only access it through pointers. Now, the other type of memory is static memory. And what that means is, if you declare a variable with the designator static on it, it goes into static memory. And a global variable is a great example of that. And sometimes those actually come in handy in class definitions, because they get stored in the same place that function definitions do when it comes to classes, and probably functions in general. But I guess those functions would be in program memory, really, and that makes more sense than anything. But the point is, though, is they kind of go in the same place as as the function members of a class do. So So anyway, they're persistent, and as a result, every instance of an object that's created based on that class can actually access that static memory. Which comes in handy, like you want to make a counter, for example, inside the class that counts how many instances of that object have been created. Well, you can do that with a static member variable. Let's see. Holy hell.